Welcome to mathlearners.com. In this video we are going to see few more examples on Vinculum and quotient and remainders. Let's say suppose we have a Vinculum number like 2, 3 bar, 4, 5 bar. We need to convert this Vinculum number to a normal number. We know the process, we go from right to left. We calculate tens complement of 5, that comes as 5, 4 will be decremented by 1, that comes as 3, tens complement of 3 gives us 7 and 1 will be decremented by 1. Now let's say suppose we have a Vinculum number like 2, 3, 4, 5 and a bar is present over 4 and 5. So using the same process we take tens complement of 5, that comes as 5, 9's complement of 4 gives 5, 3 will be decremented by 1, so it comes as 2 and 2 will be written as it is. Or what you can do is you can write this number in terms of a place value system. So if we write in terms of place value system, then we can have 2 multiplied by 1000 plus 3 multiplied by 100 minus 4 multiplied by 10 minus 5. That will be equal to 2000 plus 300 minus 40 minus 5. That will be equal to, if we group these two terms, so that will be 2300, and if we group these two terms, that will be minus 45. So that will be equal to 2255. So what in short we can do, we can consider this 23 as 23,000 and this 4 bar 5 bar as 45, and we can directly subtract 45 from 23,000. So we do not need to apply the process we usually follow. So let's say suppose we have a number like bar 119. Now we are very much aware that if first number itself is a Vinculum number, then the number needs to be, the complete number needs to be a negative. So what we will have to do, we will have to convert these positive digits to negative digits. So that is, we will have to apply conversion of normal numbers to Vinculum numbers for 1 and 9. So for 9 we will have to apply tens complement, so it will come as 1 bar, and since we applied tens complement for 9, we will have to increment 1. So by incrementing 1 we will get 2. That is again a positive digit, so we will have to take its tens complement, so that will come as 8 bar, and increment, we will have to increment minus 1 by 1, so that will come as 0. So that is equal to minus 81. Or what you can do, you can write this number in place value system, that will be equal to minus 100 plus 19, directly you can say minus 81. Let's say suppose we have a Vinculum number like 19 bar. So we can directly apply place value system. So that will be 10 minus 9, that is equal to 1. Let's say we have minus 1 bar 9, so that is minus 10 plus 9, that is equal to minus 1. This concept will be seen in division using Vedic Mathematics, using flag method and ekadikena purvena. Let's now jump to the next concept, that is how to play with quotient and remainders. In last video we had seen how to play with quotients and remainders, so few more examples I will be taking on quotients and remainders, just to make the concepts are clear. Okay. Let's say suppose we are dividing some number by 12, and for that we got quotient as 4 and remainder as 15. Now we are very much aware that we cannot have remainder greater than that of divisor, so we will have to divide this remainder by our divisor. So when we divide 15 by 12, we get quotient as 1 and remainder as 3. So now this quotient 1 will be carried forwarded to 4, so that will come as 5 and new remainder will be 3. or what you can say, what we are doing is we need to reduce this remainder. So in order to reduce this remainder, we'll have to increase this quotient. So we take 1 from remainder, 112 from remainder to quotient. So the quotient will become 4 plus 1, that is 5, and from remainder we are subtracting our divisor, that will come as 3. So let's say suppose for same number we got quotient as let's say 3 and remainder we got as 7. Now let's say for to carry out some process in Vedic mathematics, we do not want remainder to be so high. So what we'll have to do, we'll have to reduce this remainder, or what we'll have to do, for that we'll have to increase this quotient. So to increase this quotient, we'll have to take 112 from 7 to quotient. So quotient now will become 4, and from remainder we'll have to subtract our divisor, so that will come as minus 5. Let's take another. Let's say suppose we are dividing some number by 27, and for that we got quotient as 15 and remainder as 3. So let's say suppose for carrying out some process we don't want remainder to be so high. So what we'll have to do, we'll have to transfer 127 from remainder to quotient. So the quotient will become 16 and remainder will be now 3 minus 27, that is 24 bar. So this was when we did not wanted to have remainder to be greater. So let's say suppose the remainder whichever we are having is smaller for carrying out some process. So in that case we'll apply the reverse method, that is, let's say suppose we have a quotient as 5 and remainder as 3 for a number which is divided by 12. Now let's say suppose remainder which we obtained 3 is smaller to carry out our process. So what we'll have to do, we'll have to take 1 from quotient, that is 1 divisor will be added with our quotient. So that will become 1 divisor will be added to our remainder. So as 1 is taken from quotient, that will become 4 slash divisor will be added. So 12 plus 3 comes as 15. Now let's say suppose for this example, if we want to transfer 1 from quotient to remainder side, so the quotient will become 15 and 1 divisor will be added to the remainder, so it will become 27 minus 24, that will come as 3. Again, this is a very important concept when we are dealing with division in Vedic mathematics using flag method and ekadikena purvena. If you have any doubts, you can visit my page on www.mathlearners.com and you can comment on the comment section. Thank you for watching this video.